Assalamu alaikum everyone. My name is Anika Sheikh and my registration number is 2019231053. Today I will discuss about a topic of research methodology with you, and the name of my topic is measurement scales of variables. So, understanding the measurement in research. If you cannot measure it, you cannot improve it. So, measurement is all about observing and recording data in a structured way, but not all measurements are the same. So, depending on the type of data, we use four different measurement scales: nominal, ordinal, interval, and ratio. So, here in the nominal scale, data is categorized without any specific order, and examples are gender, male, female, and other, marital status, single, married, divorced, and yes no responses. Do you shop online? Yes or no? So the key rule is no ranking, no numerical value, just categories. And in the ordinal scale, data is ranked in order, but difference between them is not measurable. And the examples of ordinal scales are customer satisfaction surveys, like very unsatisfied 1 star, unsatisfied 2 star, neutral 3 star, satisfied 4 star, and very satisfied 5 star. So, ordinal scale is basically ranking with no exact difference. Now we will know about the interval scale and ratio scale. In the interval scale, data is ordered and differences between the values are meaningful, but there is no absolute zero. And the example of interval scale is temperature in Celsius or Fahrenheit, like 30 degrees Celsius is 10 degrees hotter than 20 degrees Celsius, but 0 degrees Celsius doesn't mean no temperature. It's just another point on the scale. Then comes the ratio scale. Data has an absolute 0 point. Data is ranked in order and differences between them is also measurable. So, data has an absolute 0 meaning that nothing exists at 0. And the example of ratio scale is height and weight, like a 60 kg person is exactly twice as heavy as a 30 kg person. So these measurement scales help in deciding how to analyze and interpret data effectively. Then in the next slide, we can see the scales of measurement. Here, nominal scale, ordinal scale, and interval scale and ratio scales, different type of levels like levels, meaningful order, measurable difference, true zero starting point, etc. standards are given. So for nominal scale, only level is there, and for ordinal scale, level and meaningful order is there, and for interval scale, level, meaningful order, and measurable difference matter. And for ratio scale, levels, meaningful order, measurable difference, true zero starting points, all of them matters. So here we'll talk about the application of measurement of scales in research. First of all, nominal and ordinal scales are used when data is based on categories or rankings rather than numbers. And interval and ratio scales are used when data is numerical and can be analyzed statistically. So nominal and ordinal scales are used for sorting and ranking in qualitative research, and interval and ratio scales are used for calculations and analysis in quantitative research. Here the application of measurement of scales are given broadly with examples and also with statistical applications. The examples of nominal scales are gender, student roll number, nationality, ethnicity, biological species, and the statistical application of nominal scales are frequency, percentage, proportion, mode, chi-square test, etc. And the example of ordinal scale is class rank, socioeconomic status, academic achievement, etc. And the application in statistics of ordinal scales are median, percentile, rank, correlation, range. And The example of interval scale are student grade point, temperature, calendar dates, rating scales, etc. And the statistical application is mean, correlation, range, standard deviation, Pearson correlation, t-test, f-test. And the example of ratio scale are height, weight, width, mass, and duration. And the statistical application of ratio scales are mean, median, mode, range, standard deviation, coefficient of variation, Pearson's correlation, t-test, f-test, etc. Now we'll talk about the issues of validity and reliability in measurement. So, what is validity? In research, validity refers to how accurately a tool or method measures what it's intended to measure. Ensuring validity is very crucial for obtaining trustworthy and meaningful results. So, there are three types of validity: content validity, criterion validity, and construct validity. We'll get to know about three of them. First of all, first of all, content validity. Content validity indicates the extent to which it provides coverage of the issues under study. It basically assesses whether the measurement tool fully captures the specific aspects of the concept being studied. And the example of content validity is a questionnaire studying consumer reactions to discounts should include questions about percentage discounts, buy one get one free offers, and limited time deals. If it only focuses on one type, it lacks content validity. Then comes the criterion validity. Criterion validity examines how well a given measure relates to one or more external criterion based on empirical observations. So, criterion validity basically evaluates how well one measure predicts an outcome based on another established measure. The example of criterion validity is if a credit score accurately predicts loan repayment behavior, then it has high criterion validity. Then comes the construct validity. Construct validity is the degree to which scores can be confirmed by the explanatory constructs of a sound theory. So, construct validity basically determines whether a test truly measures the theoretical construct or trait it is intended to assess. The example of construct validity is a scale measuring impulse buying behavior should assess spontaneous purchase tendencies, not just general shopping frequency. So, if frequent shoppers are wrongly classified as impulsive buyers, then the scale lacks construct validity. So, final takeaway is content validity covers all relevant topics, criterion validity aligns with real life outcomes, and construct validity accurately represents the concept being measured. Then comes the concept of reliability. So, reliability basically refers to how consistent and dependable a measurement tool is. And if the test or survey gives the similar results every time, it is considered reliable. There are two special aspects of reliability: stability and equivalence. We will talk about these two. So, stability is basically consistency over time. The stability aspect is concerned with securing consistent results with repeated measurements of the same person and with the same instrument. This checks whether a measurement gives the same result when repeated under the same conditions. And the example of stability is a student taking an IQ test today and again in a week should get the similar scores if the test is stable. And then comes the concept of equivalence. Equivalence is basically consistency across testers or items, and the equivalence aspect considers how much error may get introduced by different investigators or different samples of the items being studied. It basically looks at whether different people or different sets of questions produce similar results. And the example of equivalence is if multiple choice questions are swapped with similar ones, the result should be the same if the test is equivalent. So the final takeaway is stability is basically consistency over time, same person, same tool, same result. And equivalence is consistency across different testers, different people or methods, but the same result. So thank you everyone. This is all about my topic, and thank you for listening to me so patiently. If you find the video useful, please like, comment and subscribe my channel. Thank you everyone.